Okay, guys. Chapter 1.8. This one is about combining functions, right, and doing things with composites and plussing, minusing, multiplying, dividing functions. So question 23 to start, giving two different functions. And you notice 23, 24, 25, we're all dealing with the same two functions. 23, though, we're asked to evaluate at specific points, right? And so for those three, adding, minusing, multiplying, dividing, you can use the rule that you just basically add, subtract, multiply, divide the results of the function. So for this particular question, I'm going to do f of... Oh, actually, I'm trying to think here. Shucks, I thought the question was written so it would save me some time, but it's not written that way. Well, it will at the end for these two, because those are both 0. But let's do it like this. So f of 1 first. What's f of 1? Well, f is 2x minus 1. That's going to be 2 times 1 minus 1, which is 2 minus 1, which is 1. What is g of 1? That's going to be, g1. That's going to be the square root of 1 plus 4, the square root of, I'm sorry, I'm getting ahead of myself, 1 plus 3, I mean, which is the square root of 4, which is 2. Okay, so f of 1 is 1, g of 1 is 2. That makes f plus g of 1 equal to 1 plus 2, which is 3. So that's that first one. That's that one. Okay, now f minus g of 6 this time. Same strategy. F of 6, so this is the first one. F of 6 is 2 times 6 minus 1, which is 12 minus 1, which is 11. And g of 6 is the square root of 6 plus 3. I don't know why it keeps happening over here. 6 plus 3, which is the square root of 9, which is 3. So f minus g of 6 is 11 minus 3. 11 minus 3 is 8. So that's that one. Okay, and now the last two. Last two are nice because they're both about 0. So f of 0 is 2 times 0 minus 1, which is negative 1. And g of 0 is square root of 0 plus 3, which is the square root of 3. So that means fg, which means f times g, not to be confused with f of g. Watch out where the parentheses are. Fg of 0 is negative 1 times the square root of 3, which is negative square root of 3. Okay. And then f over g of 0 is negative 1 over square root of 3, which is negative 1 over square root of 3. That is the answer. So there you go. This was all question number 23. Sorry, I forgot again to write the question number. But that was that. Okay, sweet, done. That's not so bad, yeah. That's not so bad, right? Okay. All right, guys. 3 more from this section. Erase place. Okay, number 24. Okay, this time we're trying to find the sum difference, product division, more generally. So let's do f plus g first. F is 2x minus 1. G is the square root of x plus 3. So the result is, this almost seems silly to even say, 2x minus 1 plus square root of x plus 3. That's it, simple. Okay, f minus g, yeah, these are so easy. Okay, f minus g, 2x plus 1 minus square root of x plus 3. And that is the answer already. Yeah. I could have had parentheses to start and then gotten rid of them, but that's what it is. Okay. Let's do f times g. This hopefully be a little more interesting. Notice this is a little filled in circle, not the open circle like the composite function one. So f times g, 2x minus 1 times the square root of x plus 3. And there's really nothing we can do with that actually, guys. It's, it is just a product. I can't really simplify any further, so that's what it is. And then f over g, 2x minus 1 over square root of x plus 3. Okay, I've been missing a key component here. I'm supposed to state the domain and range of each. Oh no, just the domain. Okay, just the domain. All right. So I have the 4 boxes, right? 4 answers. Let's write the domains. Let's say D for domain. In this first one, the only issue is when x plus 3, that inside the square root is negative. That's the only issue there. So it's domain everything except for when x is smaller than negative 3. In other words, x can be negative 3 and on upwards forever. Okay, f minus g, same domain. Same domain. There's no other issues except when x is negative 3 or lower. Next one, f times g. Again, same domain. I'll write it above this time because I don't have space. So negative 3 is okay. When I get 0. On anything upwards, it's okay. Okay, and then the bottom one, almost exactly the same. This one can't have a negative square root, but also I have a fraction here. And for the fraction part, I can't divide by 0, and it's 0 if x is equal to 3. So the domain this time is a soft bracket, open parentheses, cannot be equal to negative 3, but it can be anything that's bigger than that. So negative 3, not including negative 3, onwards towards infinity. That was, again, sorry guys, this was 24 we just did. Okay. All right. So now we've got 2 more for this section. Oh, and all we have to do is we just have to take, what do you call those? Composite functions, right? We're composing functions, taking a function of a function. This is 25. Starting with f of g of x. Let's work over here. There's more, I feel like there's more space here. F of g of x first. And then see the domain, yeah? So f of g of x, that's going to be f of, what is g of x? We're going to fill that in. F of the square root of x plus 3. So what I like to do is just replace that g of x with what it is, right? And then now what does f do? It takes whatever its input and then it multiplies it by 2. So it's 2 times square root of x plus 3 and then subtract 1. And that's it. That's it. What about g of f of x? G of f of x. Okay, well that's g of f of x, which is 2x minus 1. What does g do? G takes whatever you input, which in this case is the 2x minus 1, and it adds 3, and then it takes the square root of the result. So I can do a little simplification here. Square root of 2x minus 1 plus 3 is 2x plus 2. Okay, now looking at the domains for these. Here, let's circle this first. What could go wrong? What could go wrong? This first one, same domain as before, right? The only thing that goes wrong is if this inside the square root is a negative. So domain is going to be negative 3. It's okay if it is equal to 0, upward to infinity. Okay, what about this guy? Okay, so now we have this thing, same issue though. Thing that could possibly go wrong is if this inside the square root is a negative, right? So let's do some little side work here. We want to make sure that 2x plus 2 bigger than or equal to 0. So 2x is bigger than or equal to negative 2. Or x is greater than or equal to negative 1. So that's going to be our domain too. So the domain is x is bigger than or equal to negative 1. It can be negative 1. If it's negative 1, I'll just get 0. And 0 is okay as an answer. But anything smaller than that is not okay. It's going to have a negative square root. And that looks like it. That's it for that one. Okay, 26 now. Last question for this section. Just one more question. Yeah. 26. Okay, find two functions g and h such that f given is the combination of those two. So remember we had like a few step process, right? First, we just pick some function that has all the x's in it. And to me, the most obvious choice, now this is not the only choice you could make. You could have, there's multiple correct answers here. To me, the most obvious choice is to pick this guy as the inside function. So the inside function being the one that happens first, yeah? So g of x is going to be 2x squared minus x plus 1. And then the next step was to write f, oh, I'm sorry, no, this is going to be the outside function h. Yeah, h of x is equal to everything else, but replacing, anytime you see that, just replace it with x. So it's going to be the cube root of just x and then minus 4. So that's it. That's it. Those are my two functions. Now let's do a quick check though to make sure. So to make sure, I want to make sure h of g of x is indeed what I want it to be. So what is this? What's h of g of x? That's going to be h of g of x, which is 2x squared minus x plus 1. And what is h of that? H takes whatever is input, and then, which in this case is 2x squared minus x plus 1. Takes whatever's input, and it takes the square root of it, cube root, I mean, and it subtracts 4. And look, the result is exactly what we were hoping it would be. So that means these check out. So that's it, guys. That's it. All right, we're almost there. We're almost finished with the review. And yeah, hopefully you've been breaking this up over, several sessions, so you don't just kill your brain. So make sure you're resting in between, which I'm not doing right now.